In this series of videos, we are going to continue and finish up the topics of both inheritance and polymorphism. So we've previously talked about each of these topics separately, and we're going to talk about some of the final ideas related to both of these topics in the series today. So before you begin this series of videos, make sure you have a good, strong understanding of course, class design, and then inheritance, and also polymorphism, because we're going to be building directly on these concepts with the material that we're talking about in this series. So here's a very brief review. These are the core components that we put inside of all of our classes that we write ourselves. Remember that a class is a blueprint of what objects will look like. Creating that class file, creating that blueprint doesn't actually create any objects, doesn't run anything, doesn't invoke any methods. It just lays out what the objects will look like, and it does so by specifying their characteristics through private instance data variables, by specifying how you create objects with the constructor or constructors, by providing public getters and setters to allow classes to access the private instance data variables, and including appropriate checks on the validity of that information so that outside classes can only update the variables in ways that we want to allow. Then we've got a toString method, which provides a text representation of the object. This method is overridden from the object class. Also overridden from object is the equals method. Equals provides a way to test whether a current object is logically equivalent to some other object of the same type. So we basically provide a way to compare the instance data variables that describe two objects to determine if those two objects are, quote, the same. So that whole set of things is the core components that go into all of our classes. And then once we have those kind of main building blocks, we add on any other public or private methods that are specific to that particular class. So again, this is the blueprint of what all the objects of this type are going to look like, and we define that blueprint in the class. Once we've done so, we can go into another class that does have a main method that is going to run into a driver or a tester class and actually create objects of that type, invoke methods on those objects, and so on. Now we can also reuse classes we've designed by inheritance. So if we write a class that describes an object, we can write another child class that uses that parent class that we've already written. And in order for that to make sense, we want to make sure that the relationship between the child and the parent is an is-a relationship. In other words, it makes sense to say the statement, child is a parent. So whatever the child class is, that it is a type of the parent class, it's just a more specific kind of that class. When we use inheritance, our child class inherits all the variables and all the methods from the parent class. So it gets access to all that code that we wrote. Now, if variables are private in the parent class, then they're still inherited into the child class because they still describe the child object, but we can't directly access them. In our child class, we do get all of the functionality, so all the methods inherited, but we can choose to override some of those methods if we want to completely change the functionality that was inherited, or if we want to keep the functionality but then just add on a little bit more to what the child method does. If we want to change the method completely, we just use our @override symbol and then we write a new implementation. If we want to do what the parent version does but just do a little bit more, we use the super.method name, and that invokes the parent version of the method. And then after invoking that version, we can write additional code to complete kind of the child part of the method. We can also use the super keyword to invoke the parent constructor, which we almost always want to do explicitly. What this does is it says, hey, parent class, you're in charge of setting up certain components of the object, so you do your setup with the parent constructor, and then after we call that constructor, then we add on additional lines of code to set up the child portion of the object. After we talked about inheritance, we talked about how that relates to polymorphism. So polymorphism all centers around the idea that objects really have two different types. They have a declared type, and that's the type that goes in the declaration statement. So right when you specify the type and the name of a variable, that's that variable's declared type. The declared type is used to determine what methods you are allowed to invoke at compile time. So at compile time, the compiler looks at the declared type of an object and it makes sure that any methods you want to invoke on that object exist in the declared class. If a method doesn't exist in the declared class, you can't compile. But objects also have another type, and that's the actual type. And the actual type is based on what the real type of an object is. So for example, you could declare an object to be of the parent type, but then you could instantiate it rather, to be of the child type. So in that case, the actual type of the object would be the child class, not the parent class. So at runtime, it's this actual type that's used to figure out what version of a method is run. So if a variable is declared as the parent type and instantiated as the child type, if a particular method exists in the parent class, then we're allowed to invoke it on that object. But if that method is overridden in the child class, then it's the child class version that will get called at runtime. Okay, so we always have these two types that we need to think about with an object: the declared type, which we need to consider at compile time, and the actual type that we need to consider at runtime. And any classes that are related through inheritance, we can declare the type to be the parent class, and we can then initialize to be the child class. So basically the left-hand side can be high up the inheritance tree, and the right-hand side can be anything lower on the inheritance tree. Now, if at runtime we do want to actually invoke a method that is only declared in the actual types class and not in the declared types class, we use a combination of the instance of operator as well as a downcast in order to tell the compiler to temporarily treat that object as that more specific type. And then that allows us to invoke a method from that class. So that is a very, very brief review, but hopefully all of the topics that I just went over are very clear to you and you understand all of them. If you don't, you should pause this video, return to the prior videos, and brush up on those topics, because we're going to be building on all of those topics in this series.